Hello, welcome to Operations Management. In this lecture, I will talk about product life probability. So, in this, we are looking at how long a product will last without failing. So, this is uh, how long a product will last without failing. So, this is with respect to time. So I want to introduce a term called mean time between failures. So MTBF, we will call it. It's called mean time between failures. So this means actually it's an average length of time between failures of a product or component. So this comes from historical data. Suppose we have a product, we will look at its historical data and we will try to calculate on an average how much time the product will last, or after what time it will fail. We are looking at an average. So what people have observed is the mean time for failure. If we plot the data for it, it will follow a negative exponential distribution. So a negative exponential distribution looks something like this, where x-axis it's time and this is a function f of x. So this is the curve for mean time between failures, and this curve is negative exponential distribution. So this is one of the ways how companies determine how long of a warranty to give on products. So these are mostly used for warranties for products. So in an initial stage, like when you buy a new product, that is your textbook will call it as infant mortality. So that's infant mortality. So what it means is during initial stages of your product, that is when you buy a new product, this is how the negative exponential is what your product will behave, product life will behave. So now we are interested in if t is time period, what is the probability of no failure before time period t. So this would be mostly the probability of no failure before t. So that means the product will not fail before this time period. So the equation for this will be e power minus t divided by mt bf, and this is no failure before t. This is also, because it's not failing, it's the reliability of the product. So this is also the reliability of the product. So if this is no failure, then this would be the probability of failure before t. So as you know, the probability sum of all the probabilities is 1. So if this area is e power minus t divided by mean time between failures, this will be 1 minus e power minus t by mtbf. So that is, the product will fail before time period t. So this is the concept of product life probability. We will try to solve a problem to understand this concept in more detail. So this is the question. By means of extensive testing, a manufacturer has determined that its super sucker vacuum cleaner model have an expected life that is exponential with a mean of 4 years. Find the probability that one of these cleaners will have a life that ends after initial 4 years of service, and then B is before 4 years of service completed, C is not before 6 years of service completed. So the first thing is they are telling you what distribution it is following. So it is following a exponential distribution and the mean of 4 years. That means our mean time before failure, between failure would be 4 years. So that's the given information. And now question A, they are asking us find the probability that one of these cleaners will have a life that ends. So life that ends means it fails, right? So then we have exponential distribution and our after initial 4 years of service. So if our t is 4 years, which is this 4 years, then they are asking us what is the life, what is find the probability that one of these cleaners will have life that ends after initial 4 years. That means initial 4 years after would be this. So if you see when from our when we discuss the concept, this is e power minus t by mtbf. So we can calculate this. We can say e power minus t is 4 divided by mtbf is 4. So your value would be e power minus 1. So you can go, so one of the things is to calculate e power minus 1. You can go to our one of the tables. So this table, if you look at it, this has t by mtbf, right? T by mtbf values are there and it will give us so the column A is t by mtf and column B will give us e power minus t by mtbf. So one of the things in our problem says if you look at it, what is t by mtbf? So t by mtbf is this one, which is 1. So we can recalculate it if you want. T is 4, mtbf is 4, so t by mtbf is 1. So we can go to our table again and look for a value of 1. So here is we have 1, so I will highlight it with a color. So the probability would be the value e power minus t by mtbf would be 0.3679. So that is the value. So I can go here and my value would be e power minus 1 would be 0.3679, or this will be equal to 36.79%. So that's A. So question B, now they are asking us before 4 years of service completed. That means I am now looking for this area. So the formula for this area to get this area is e power minus t by 1 minus e power minus t by mtbf, right? So we have e power t by negative t by mtpf as 0.3679. So this would be 1 minus 0.3679, which is going to give us 0.6321. So question C, not before 6 years of service. So now we can redraw this again. Now our T is 6 years, and they say not before 6 years of service. That means this would be our area. So this would be e power minus t by mtbf. Since we have table, we can do t by mtbf. T is 6, and then mtbf is 4. This is going to give us 1.50. So we are looking for e power minus 1.50. So we can go into a table and look for 1.50. So that is if we go to the table, this is 1.50. I will highlight it in a blue color, and then this would be the probability 0.2231. So this is going to be 0.2231, that is 22.31%. so the thing is the product will last only 22.31 after 6 years percent after 6 years. So that's the concept. This concludes my lecture on product life probability using negative exponential distribution. Thank you.